show and tell. Google Hangouts may be gone, but we're not. We're sticking around now through StreamYard. It's me, Lady Ada. With me is Mr. Lady Ada on camera control. We're broadcasting live from the Adafruit factory here in downtown Manhattan, where we do all of our testing, design, shipping, manufacturing, coding of electronic goodies that you love to use in your projects. And speaking of projects, that's what we're doing for the next 25 minutes. We're doing a show and tell with people from the Adafruit and Further community. What are they 3D printing, soldering, coding, cosplaying, hacking, whatever it is, come by and show it off. We would love to see it. I'm going to start off with some Adafruit folks, and then they'll drop out and we'll get other people in and exciting thing about StreamYard. And there's pets. People have
Baby, come here.
All right, can't help Brian with that problem.
All right, who you want to start with?
But we'll start with Brian because now he's
Hey, sure, why not? I didn't have my mic off, so here I am. So I've been doing a bunch of things, chasing my dog around, chasing my cats around. One of the things I've been working on most recently is the CircuitPython driver for the MSA 301 super low cost accelerometer. You can see I've got the plotter going, all the basic accelerometer bits and bobbles. You know, it does stuff. It's an accelerometer. You leave it alone, the lines are flat. You move it around, the lines aren't flat.
That's a very good scientific explanation of what an accelerometer is. Nice work.
Yeah, I try. And then I've also obviously been doing Eagle stuff as I do just about every day. So let me switch over to Eagle here. Okay, I got my Eagle window open. So this is a PCT 7025. It's a temperature sensor with a thermal watchdog, so you can have it warn you when a temperature threshold's been surpassed. It's got the STEMMA QT connectors like all our new I2C breakout boards. And yeah, it should be a pretty fun little guy. I've been also working on a personal project. This here is, I'm calling it the Eagle Pad. It's a 8-key keyboard. It's going to run KMK, which is the keyboard firmware that's based on CircuitPython. Down here, I've got a NRF 52840 and a bunch of support circuitry. All of these guys are super clicky buttons. You can hear how clickily delicious they are.
They're very clickily delicious sounding, yeah.
They're so clickily delicious that I think I'm going to make a 1-key keyboard that doubles as a fidget toy.
Yeah.
So, yep, that's what I'm up to.
Oh, wow. This is a party.
Thanks so much. And new feature in our newsletter every week, the Python on Hardware newsletter. You can see what folks like Brian and Dan and Scott and Kenny and Melissa and a lot of the team are working on. So look for Brian's stuff next week as well.
KMK8 keyboard. Okay. Cool.
Thanks so much,
Next
Brian.
up, let's check in with Dan. Dan, how are you doing?
Okay, so I'm working on BLE and still debugging BLE HID, but I just got my Circuit Playground Bluefruits from UPS. They came today and I was trying them out, and there was one small bug which I just hacked a fix for, so I can demo something for you. The CP Bluefruit running CircuitPython with the BLE libraries. So I had a previous demo that I showed before where I have like an RGB controller, these 3 knobs for RGB, and I was using a Feather 52840 and some NeoPixels. But now I have...
One is acting as the central, one's acting as peripheral.
That's right. So you turn the knobs and the color changes. So now I have a Bluefruit doing that, and since I don't have 3 hands here, you just will do this.
Okay, this is very scientific.
All right, there we go. Get out of the light here. And I think it's kind of hard to see the colors.
It's like a reddish color, now it's a yellowish color.
I'm changing the color, turn it up, now I'll turn it back down. And the little glitch you see as it goes around is that one of the NeoPixels is still acting as the status NeoPixel. I need to turn that off.
Yeah.
But it's the same demo as it was before. Now running on the Circuit Playground Bluefruit. So we're going to fix that up. All of you who got the alpha ones will have a build for you really soon that you can try Circuit Playground. The Bluefruit code on the Circuit Playground.
I'm just glad you fixed it and it wasn't some hardware bugs. I'm like, damn, we just shipped 120 of those, so hopefully it wasn't hardware.
It was a clock problem. It has to do with using different crystals. As the more pointed out to me, we're using a different frequency of crystal high frequency crystal instead of a low frequency crystal. And Circuit Python wasn't expecting that, but it was an easy fix. And
I think the module you're using, they have both. They have both. The internal one is 16 kilohertz or megahertz, and the external is 32, or is it really just one?
Well, there's a low frequency and a high frequency clock. So you put a 32 megahertz on the Feather. You have a low frequency 32 kilohertz crystal, and on the Circuit Playground Bluefruit, for space reasons, you put a 32 megahertz crystal, and we did not expect that in our code. So it's really the fact that it worked at all was an accident because of what the bootloader.
Yeah, weird. Okay.
So
all right.
Okay, cool. Thanks for the update and thanks for the coding. And I'll take a look at if it makes sense for us to move to a low frequency crystal. I can maybe move that one part. All right, thank you, Dan. Next up, let's check in with Melissa.
Hello.
Hi.
Okay, so I have a sign here, which says the show drills in progress, actually. But I can change it with a Stream Deck here, just by pushing different messages.
Welcome.
And you can do like.
I like this because it's like an A meeting.
And then,
oh, that's interesting. In an audio only meeting, so someone could see that and like, oh, cool, I can
come and grab something.
I can sneak by quietly.
Exactly, and it's really easy to just add custom messages because it uses a custom Stream Deck plugin, and I can just set the value right in the Stream Deck.
Can you show the 3D printed case you did? It was so long.
Oh, yes. Yeah. This is actually the first design I've done in Fusion 360. I've done OpenSCAD before, but this one holds like the Metro M4 on here. Oop, there you go. And it's actually in two pieces so that you could actually print it on a standard printer, and I just made these tabs in here so that it holds it. And then what's kind of cool is on these holes here, that you put them in with a standard screw. They have to be a steel screw because these displays come with these little magnetic screws, and then it'll stick right on top of those existing screws, and then it comes out without showing any existing.
Nice.
Holes.
We have a question from the audience.
Does it work with images or just text?
Currently, it works with just text, but it could be the firmware can be modified to do images too.
Okay.
All right. Well, thanks for answering that question, Melissa.
All right.
And thanks for the demo. All right. Next up, let's check out JP because he's antsy.
Hey, yeah. Well, look, I'm excited because I got the monster mask in, and I'm starting to work on some customized eyeballs for it. I'm going to actually switch cameras here so you can see this better. The exciting thing, I think, is that we've now got a really accessible setup for adjusting the graphics. So here I'm actually doing a bit of an inside joke among CGI people. I'm using a reflection map. It's the St. Basilica reflection HDR high map, and normally a reflection map sits still and doesn't move around. So this is really just me testing things, but getting images onto the eyeballs now is pretty straightforward. We can use BMP graphics, and we don't have to convert them into hex tables and use command line tools. You can actually save them right onto the drive that shows up on your machine, and use a little config file to do things like rotate them and mirror them and set their boundaries. But there's really just two maps. I happen to have seamed them together right now so that they look like one. But I'm going to be showing a bunch of examples tomorrow on my show of different iris and sclera maps. Those are the two maps that we have control over, as well as how to create those, how to design them, how to pre-warp them, how to undistort them so that you can get images that don't look distorted once they're turned into a sphere, even though you're starting out with rectangles. So a whole bunch of kind of cool texture mapping things that I'll show that will, I think, be really useful for people who are doing costume and prop creation for their eyes and want a very particular look beyond the cool standard examples that we're going to include. So that is what I'm working on.
Yeah, and you've done graphics animation your whole life, so this is perfect for you because you're like, oh, I understand. Like you're mapping it into a toroid, and I've done that.
Yeah, it's really fun.
And you had like a plug-in for like Maya to help you like visualize. It's like, what is going on here?
Yeah, yeah. I'm going to go over the top and use some 3D software just to help explain how the mapping works, because I think getting from what's often called UV mapping in the 2D coordinate space and the texture space into a 3D object can be confusing until you see just that one right demonstration of it, and hopefully that'll help people who want to create their own custom eyeballs.
All right.
Thanks so much, JP, and see you on video tonight with things that we're going to show on Ask an Engineer, and then tomorrow at 4 p.m.
Yeah, see you tomorrow on the live show.
Okay, check that. All right, Noah and Pedro, what are you 3D extruding this week?
Yes. Hey, everybody. Hey, guys. So it's near the end of the summer. So what was it? 2 weeks ago, Halloween started.
That's right.
So I know, right? Like every
It's
store has
mid-August. I mean, if you go to Michael's, there's skeletons, and that's how you know.
Yep. I think it's been up for like a month. We're doing our Halloween decorations next week. Tomorrow, actually. Yeah.
Yeah, you get it early.
Yeah. You have to be early, right? So
well, there's nothing in September like Labor Day. Like, what are you gonna do, right?
So we figured we started with our projects that take forever to print. So the first one is this SpaceX helmet. Yay! So the the Starman just completed its first orbit around the sun. So we're kind of celebrating that with a 3D printed helmet. So a lot more modern, I think, than the usual helmets that like people who dress up as astronauts use. And what's cool about this is that it's fully articulated. So we have a Circuit Playground Express inside there that is handling, it changes the lights when you change the orientation of the board that's inside there. And we added a USB connection right at the front. We got the little slide switch on there. We even added a little LiPo charger on the side so you can charge up the helmet.
You got a cute dog.
Oh, yeah. He's waiting for
eyes and staring at you.
Hurry it up. We need to go walk.
I know.
I know. It's like, you're trapped. You're like 15 years of that.
Right. So printed a bunch of different parts. It takes about 4 days on 5 different printers. So if you only got one, you got to start now to get it by then. Yeah. So tons of different pieces. We talked about
bribe your friend with an Ultimaker.
Oh my God. Yeah. So we have a full hour on all the techniques that we use on assembling this. Lots of cool details on just assembly on it, and then lots of craft that actually went into making all of that. So lots of
I love the field in the front. You did a great job with it because it's definitely like spacey, but you can see through it. But it feels like there's a grid. It feels like there's like a grid inside of a glass or something.
Yeah, I looked at a bunch of YouTube videos on like making the visor, but we sell electronics. We don't do.
No, it's like before you know it, you're like researching vacuum formers at 4 Bad scene.
I was like thinking of space where to put it. I was like, who do I know?
I'm telling you, don't do the vacuum former thing. I know so many people who've done it, and it's never ends.
And then I think the best excuse I think that I can come up with living in Florida, I can actually wear this without having to die of how hot it is and having to install like an air cooling system or something. So went with the Veranoid design of that. So we talk about that on 3D Hangouts. We give away the files, of course, and we go over how the code works. So definitely check that out.
All right. Thank you, Spaceman.
And we'll show the full video and build on Ask an Engineer tonight.
Yes.
Okay, next up, Scott Inc. Oh, wait, what?
Is that everything?
You have something else? No? Okay, sorry. All right, Scott Inc.
Hello. As you may be able to tell, I've gone a little e-ink crazy.
That's weird. Run 2. There we go.
Sorry, Jay.
Oh, is it not?
Yeah, it's fine.
No, keep going.
When someone left, it went to the other screen, but now you're back.
No, it doesn't look very focused, does it? There we go. Look at that. Yeah, so these are important to note that these big ones we don't carry in the store. I bought them off Amazon. They're WaveShare modules. And we were actually just talking about this. There's tricolor e-inks. You can see here that we have red, black, and white. And then this is a yellow black and white, but it's actually really hard to see the circuitpython.org to the degree that Lady Ada was saying that she doesn't want to carry them because of that inconsistency. So if you really want the yellow ones, take a look at other places to grab them.
Yeah, Waveshare has them all, but I'm like, I can't stand when it's like inconsistent color.
Right.
Wash.
Yeah, we're kind of held to a high standard.
Yeah.
So if we don't have the best possible,
I think they'll improve it. We'll carry it when we'll carry it when it's good enough.
Right.
Yeah.
So a pro tip is if you do get these modules, you can. I found the modules only on Amazon, not the just bare screens, but you can actually undo the tab on there and then use the Adafruit e-ink friend, which has kind of a more standard pinout. So that's what I was actually doing, because then I don't have to worry about exactly how this circuitry works. I actually got burned by one of their OLED modules that way. So yeah, been working on that. And along with this comes a bunch of refresh stuff, changing the way that we manage refreshing screens. So I'm currently working on getting a build for the monster mask of CircuitPython and discovering that it works for e-ink right now, but it does not work for OLEDs and other displays. So I'm working on that pretty much as we speak.
You'll figure it out. I know you will. And then do you want to, Phil, do you want to go to our overhead to show the e-ink, or just move it later?
No, because everything's working out right now.
Okay, that's what I'm supposed to move really well. Sorry, you're right. All right.
Yeah, we'll show some fun e-ink stuff on Ask an Engineer.
All right, well, let's go to Jay, because we kind of previewed Jay.
Yeah, that was the Jay.
Thank you, Scott, for your e-inks.
Hey everyone. So I've got a bunch of stuff going on, and one of them is I want to do a little bit of robotics and want to play around with LoRa. And one of the things I ran into almost right away was I didn't have a reliable way to transmit over LoRa. I didn't have a way to do kind of basic motor controls. So I had an Adafruit joystick, I had a feather, I got a trigger off of McMaster car, and I just bought an SLA printer, which is really toxic, but also a lot of fun. And I made this. It looks kind of scary, but all it is it's got a feather in here.
Yeah.
And it maps the joystick to the analog. So it just reads X, Y. And then it's got a trigger on there.
Ooh, nice NASA style, wire bundling there.
Yeah.
Thank you. So, and then I'm kind of proud of this. It's kind of hard to see, but this little plastic part holds just the wire antenna. So it's a one-piece plastic piece, and you can see it's got a triangular shape in there. So it looks kind of ominous. The joke is that it looks like a detonator on a movie or something like that. But it's pretty basic, and it runs CircuitPython. So I can plug it into a computer. There's no battery or anything like that. I can plug it in. The code shows up. I can tweak it, and I have it broadcasting just raw LoRa, not LoRaWAN or anything like that right now. The one thing I'll add is that this, like with all of my builds, what I do is I take a picture every day, and then I have, or actually I post a picture every day on my Instagram, and I have the world's lowest tech plug right there.
All right.
Oh yeah.
Log in and get your Instagram. This looks cool. I mean, like the techniques you're using colored heat shrink, and you've got the hex topped screws, and those boxes look beautiful. People who are making electronics, they want them to be durable. Like if you're building stuff for Burning Man or outdoor use or anything rugged, this is how you want to build it.
Hold up your Instagram. Hold up that sticky again.
Yeah.
That number again.
That number again. So the thing is with this in SLA printing, the resolution is super, super high. So these parts are all really smooth. I can do really small prints, and I'm not using any supports. I'm putting them directly on the build plate, so that some of these parts, like this lid, printed in like 30 minutes. So it's super fast because it's a super flat piece. But yeah, and then I use M5 screws. My new favorite thing is using M5 and M2.5 screws for everything. So I have a big box of each, and whenever I make anything, I don't have to go out and buy new parts. So that's what I'm working on.
Yeah, great Instagram and nice photography.
Cool, thank you.
All right, sweet. All right, That looks cool. Everybody subscribe to that because you'll learn a lot of good tips and tricks. Next up, let's go to Matt Costi. Hey, Matt Costi, welcome. Chantal, what are you up to?
Hi. So if people have seen me in the Discord the past month or so, I've been working on getting some server functionality for the ESP32. And the reason I'm doing that is for my big project here. It's LED light stick.
Yeah.
And I'm going to be using it for light painting.
Okay.
And so on the server is because so that way I have made a web app.
Ooh.
And so that way I can take a picture on my phone or load a picture that I've already taken.
Yeah.
And then I can send the picture over to it like that.
Okay.
So it's just a send over bitmap. And then I can click the display button on my phone. Hopefully it works.
Yeah.
And
that's so cool. I love how you're like, you really wanted this user experience and you're like, I'm willing to put in this extra effort to get that working because you just really wanted to have that web app. It is nice, especially like if you're out and about, you can switch images. That looks like a really nice 20 design.
Yeah, that was the big thing. I wanted to be able to switch images really fast and just the better UI. I'm a web developer, so it was more comfortable for me to make the UI that way.
All right. Well, congratulations on getting your PR in. You did amazing.
Yeah. And this was for Jay, who was there. I think he'll get a hold of us, but email support@adafruit.com, get a show and tell sticker. Same goes for you, Matt, as well.
Okay. Well, even though your project's finished, please stick around the community. We love your contributions. They were awesome.
Yeah.
I'm so grateful that you were able to add that code. I know a lot of people were asking for it, and I just was like, I don't know what I'm doing. And you were like, I know what I'm doing. Or at least you faked it really well, and you did it. And as you do more projects, just stick around and let us know what we can add, or if you want to volunteer to help add it. And that's how we all share code and make things better.
Absolutely. Thanks.
Nice light stick, too.
All right. We're going to go to Bill, then Roberto, then Chris. If you can keep it to a couple minutes each, we can get everybody and then move on to Ask an Engineer. Take it away, Bill.
Hi, guys. Can you hear me okay?
Yep.
Yeah.
All right. So I am not in my studio, obviously. I am in the gym. And because I've got an insane demo, and it might totally fail. But that's always true, right?
That's cool. A lot of demos.
I know. So it's supposed to be sharing my screen.
Okay. Do that, and then we'll add the screen.
Yeah.
Okay.
All right. So if you remember Lamore, ages ago, you and I talked through a DigiKey conversation about finding this potentiometer. Remember that?
Yeah, and that's the one I picked.
That's the one you picked, and then
this is the best one.
then you put it on a board for me about 2 weeks ago. I don't know if it was for me, but I'm saying it was. For me.
Yeah.
And so I went ahead and I made up a circuit like this because I wanted to mimic a analog joystick that we use in AT, and it worked. So I went ahead and got a board made, and I made a feather wing that takes your 2 pots and some voltage dividers, just 6 resistors, a reset, and an optional LED for status, and a DB9 jack. And what this lets me do is it lets me control a number of different devices in AT, but one of them is it might let me do a better job with Ella on her driving. And it might help Chris as well. If he can't use his joystick that he uses with his lip anymore, it actually should be able to give us the ability to mimic a joystick. This is a virtual joystick that is controlled by a feather. So it's awesome. It is a virtual joystick wing. And I have it hooked up. I thought if I was going to prove that this worked, the hardest thing I could use would be an FSR to see if I can drive it with 2 FSRs, because that's the lightest touch thing we have for people who can't lift their fingers. So I resurrected Barbie. I resurrected Power Chair Barbie, and I have her working. So if it works, I would like to show her working, which shouldn't be that hard. Let me see here. But I needed room. So I do have a helper. So thank you, Lori. So I've got the control in one hand with one of the FSRs, and I've got the other FSR in my other hand, and I can now do fine control, right? So when I go left, I go left, I go forward, run over stuff. But you'll see that this actually gives me complete control over it, and you can't even tell my fingers are moving, right?
Yeah, that's like really tiny movements that's doing that.
That's pretty.
Isn't that cool?
Yeah. One tip, by the way, if you want to save space on your Featherwing, is you can stack the two DS3502s on top of each other, like the holes line up, and then you just set the address jumper on one of them to be low. If
Yeah, so did you put I'd have to take it off to look. Did you put a pad on it for setting the address?
Yeah, I'm pretty sure we did.
Okay. So that's wonderful. But I have it on a tripler just for the demo. I have it sized so that it'll stack and fit in a nice little box.
Well,
I'm real excited about this. It's not something I can like sell. We don't sell controllers for power chairs. That's just a bad idea. But for things like Chris and Milad and Max and Ella, who are already using something very custom, it gives me something other than on-off, right? It gives me control that lets me do that. And I'm really excited about it. So thank you for making that.
Thanks for asking me which potentiometer to get, because that kind of made me think we should have a breakout for it.
Yeah, and it had to be 12 volts to do this, and it is, and it works. So that's running at 3 volts, but I tested it at 12. It works there as well. So I will do another demo for you on a real chair when I can do that.
Okay.
All right.
Sweet.
Well, thanks so much, Bill.
Thanks, Bill.
If you want a sticker, of course, Barbara, you can get a sticker for that chair.
Sure.
When I get a hold of us. All right. So we're going to go to Roberto, then Chris, then Speedwell. And speaking of speed, please, everybody, keep it to about a minute, and we can get to everyone. So take it away, Roberto.
Hi, everyone. Can y'all hear me well?
Yep.
Yeah.
Okay, cool. I'll make mine real quick. I was revisiting some Featherwing projects, and I wanted to get an internet clock over a Huzzah feather. And then I tried it on the dot matrix wing, but 4 characters didn't quite fit on there. So I was thinking of other ways to present the time, and I remembered that Tix clocks, you can make them fit pretty much anywhere where you got a bunch of LED, where you have an LED matrix. And so that's what this one's doing. It's looking up NTP and updating every 20 seconds and relocating what dots are lit. So here's the hours tens, here's the hours minutes, and in red is it's easier to see in person.
No, we see it. Yeah.
Okay, cool. And then minutes tens and minutes ones, and then I to help better distinguish which LEDs are in which rows. I designed this in OpenSCAD as just like a frame to cover up and act as the plate in the front.
Okay.
All right.
All right,
Thanks so much.
Yeah.
You know how to get a hold of us for a sticker? All right.
It took 1 NTP minute. Next up, Chris.
Hi, can you see me?
Yeah.
So I was on the show last week showing these wall-hanging Raspberry Pi systems. I'm going to be writing a learn guide on how anyone could make one, taking one of these art canvases, starting with that, and then building the computer parts onto it behind it. And so the guide will be mostly about the hardware construction. I'll have a few little bits of software. I wanted to quickly show one little thing here. So when you boot one of these up, I have a script that runs, and it should make some sound.
Oh, yeah.
Yeah, it was speaking.
Yeah, and then it'll...
IP address 192.168.
So it tells you the IP address because when I've taken these to meetups in the past or to a friend's house and I plug it in, that's the first thing you need to know is what's the IP address. So when it boots up, that script runs. So that's all I wanted to show today. But when I have the learn guide ready, I'll have a compute canvas that I build that goes along with it, and I'll come back and show that.
Everyone's heard of voice over IP, but now you have IP over voice.
Yeah.
You get a sticker.
Yeah, get a sticker. And also, we added your stuff to the newsletter. It was great. We had a lot of art projects with CircuitPython this week, so thank you.
Thank you.
All right.
Speedwell, play us out.
Welcome.
Hey, just a quickie here. About 3 years ago, I was on Show and Tell with this prototype of this, where it's a GPS with a trinket connected to the audio FX board, and when you got to certain locations, it played a sound.
Neat.
I decided to take it back. The limit on that was that the Audio FX only had the 10 individual pins, and a Trinket couldn't run 2 serials at the same time to talk to the GPS and to the serial mode. Redoing it now with a Trinket M0 and the Audio FX in the serial mode. I was wondering, I found the Python library for the Ultimate GPS. Is there a Python library for the Audio FX?
I don't think so, but you know what I would recommend is actually upgrade your project to like a Trinket M4, because then you can store all the images on it, and then with CircuitPython, you'll be able to read the GPS and just play the WAV files directly, so you don't need that third board at all.
That's a good idea. Thank you.
Okay, great. See?
All right.
That's why it's a good idea to come by and show and tell. You never know. You might save yourself a couple bucks.
You get a sticker then.
I get a
All right. Well, you get a sticker. So
yeah, but
Adafruit.com.
Itsy Bitsy M4 is probably what you want. That's going to be the smallest.
Okay.
Thanks again.
Okay.
Thank you so much.
Thank you, everybody.
Okay. Thank you, everyone. This is, once again, our favorite 30 minutes that we have each week. We're here every single week, 7:30 p.m. Eastern Time. Show and Tell and Ask an Engineer will start in just about a minute. We'll see everybody later.
Thanks, guys.